was stated in your last that in physics, work is done only when a force is applied to a body and it moves it. So meaning, if you applied force on a body and it doesn't move or there's no displacement, then there's no work. So sabi nga, it is the product of force and displacement resulting from the application of force. Though the force and displacement are both vector quantities, work is a scalar quantity. Okay, so we have the formula for work. Work is equal to force times displacement. Okay, so force and displacement, they are both vector quantities. But work is a scalar quantity. Okay, so if the displacement is in the x direction, then there is a component of the force also in the x direction. So tatandaan natin na lagi ang force ay nasa direction ng displacement. Okay? And kung yung displacement natin nasa y direction, si force ay nasa y direction din. In the first picture, so for instance, you lift a bag, or specifically a heavy bag, you're going to apply force to it. But if it doesn't move, halimbawa hindi mo siya nabuhat kasi nga sobrang bigat niya, then there is no work done. Okay? Same thing kung kayo naman ay nagbibitbit ng bag. Okay? So yung force na ina-apply mo para mabitbit mo yung bag is pataas. So kung pataas yung force mo sa pagbibitbit ng bag, halimbawa ikaw yan. So bitbit mo yung bag, upward yung force mo. Pero kung ikaw ay naglalakad, then yung displacement mo is in the x direction. Okay? Wala pa ring work done dyan. Kasi nga, hindi pareho yung direction ng iyong force at ng iyong displacement. Okay? Yung force na ina-applied mo, ay ina-apply mo lang para mabuhat mo yung bag. Pero kasi, hindi naman gumalaw yung bag ng pataas. Gumagalaw ka ng in the x direction, or patabi, or papunta sa kanan, or papunta sa kaliwa. Tandaan natin na ang work, dapat kapag nag-apply ka ng force, yung force na yun is nagkukos na yung object ay gagalaw. Okay? Or magkakaroon ng displacement. Another example dyan, so halimbawa daw, binatak mo yung bag mo. Okay, so you applied a force with 30 newtons. Okay, parallel to the ground. So, meaning in the x direction. Okay, and then, to your classroom, 20 meters away. Okay, so yung displacement mo is 20 meters away daw. So, ibig sabihin, nagkaroon ka ng 20 meters na displacement. Okay? So, syempre, automatic in the x direction din yan. So, simple lang para makuha natin yung work. So, force times displacement. So, 30 newtons times 20 meters. So, ang sagot natin is 600 Newton meters. Or sa work, in specific na unit natin ng work yung joules. Okay, so ito yung final answer natin. Sometimes there are cases na kapag nag-apply tayo ng force na sa isang bagay, hindi siya exactly in the same direction ng displacement. Pero hindi naman siya opposite. Ano ibig sabihin nun? Pwedeng halimbawa yung sa fourth picture natin. So, halimbawa yung bag, halimbawa is yung bag. So, halimbawa merong wheels yung bag. Batak-batak mo siya papunta sa right. Okay, so yung displacement natin in the x direction. Kaya lang, meron siyang handle. Hawak mo siya sa handle. Okay. Yung force na in-apply mo dun is diagonal. Okay, or nagkaroon ng angle dito. Okay. So, kapag meron tayong cases na ganyan na nakakabuo tayo ng angle, ang kailangan lang natin gawin is i-multiply yung formula natin sa cosine theta. So, magkakaroon tayo ng formula na work is equal to force times displacement times cosine theta, kung ilan yung angle na yun. So, sa example natin dyan, if the bag is pulled in a manner that is shown on the right, or on the left in this case, force that is doing work is the force component of F, which is in the same direction or in the x direction. So, sabi nga natin, kahit hindi siya exactly na nasa x direction, okay, dahil papunta nga tayo dito sa right, okay, yung displacement natin papunta sa right, in the x direction pa rin siya, kahit yung mismong force na in-apply natin, hindi exactly naka-x axis. Okay? The work done is, so, substitute natin yung values. So, yung force natin, same pa rin nung given natin sa una. Okay? Na iba lang yung scenario. So, 30 newtons times 20 meters times cosine. Ilang degrees ba yung nasa example? So, 60 degrees. Okay, so yung nakuha natin kanina, 600 Newton meter times cosine 60 degrees. So, cosine 60, 0.5 times 0.5. So, we will get 300 Newton meter, or again, unit natin for work is joules. So, 300 joules. So, that is work. So, like other quantities, we can also represent work using graphs. Okay, so we have a sample. How much work is done by a constant 50 Newton of force that acts over a displacement of 10 meters? So, to solve that, kailangan muna natin gumawa ng graph. Okay? So, kailangan, syempre, meron tayong y and x axis. So, lagi natin tatandaan, ang displacement natin is sa x-axis at ang ating force ay sa y-axis. Okay, so sa given, meron daw 50 newtons of force. So, maglagay na rin tayo ng ibang amount. Okay, so 10, 20, 30, 40, 50, 60. Okay? And then displacement is 10 meters. Say for instance, dito is by 2. So, 2, 4, 6, 8, 10. So, kapag pinlat natin yung problem sa ating graph, so 50, sabi dyan, 50 yung ating force. Okay? And then, yung ating displacement is sa 10 meters. So, kapag nag-draw tayo ng line, so they will meet at this point. Okay? So, paano natin kukunin yung work dyan? So, ano ba yung nabuo nating shape sa ating graph? So, nakakuha tayo ng, or nakabuo tayo ng isang rectangle. So, in using graphs to get work, kailangan lang po natin kunin ang area ng kung anong shape yung nabuo natin. Okay, so in this case, we had a rectangle. So, ano bang area ng ating rectangle? So, length times width. Okay? So, the same lang din yan ng work is equal to force times displacement. Diba? Kasi yung ating length, ito, yung ating displacement, or yung ating force rather, and then yung ating width is yung ating displacement. So, to get that, so 50 newtons times 10 meters. So, we will get 500 joules. Okay? How about dun sa ating pangalawang problem? Tatandaan natin na yung work kapag gumagamit tayo ng mga graphs, yun yung area ng curve natin or kung ano man yung natamaan ng ating line. Okay? So, in this case nga, nakabuo tayo kanina ng rectangle. Okay? How about dun sa second example? So, gawa ulit tayo ng isa pang graph. So, displacement, force. So, dun sa ating second example, how much work is done by a varying force that increases at a constant rate from 40 newtons to 80 newtons over a displacement of 10 meters. So, same displacement pa rin, kaya lang yung force natin, anong nangyari? So, nag-increase siya. So, meron tayong dalawang value ng force. So, gawin lang natin uli yung graph. 2, 4, 6, 8, 10. Okay. So, gawin natin 20, 40, 60, 80, 10, 20. Okay. So, dun sa problem, sabi, nag-increase daw yung force from 40 to 80 newtons. So, 40 to 80 newtons. Okay, so yung starting point natin sa 40 going to 80. And yung displacement uli natin is 10 meters. So, kapag gumawa tayo ng line, so, hindi lang siya hanggang sa 40. Kasi, nag-increase nga yung ating force ng 80. So, mula dito. Okay, kaya lang hindi tayo magdodraw ng line dito. Kasi hindi naman siya constant. Nagbago siya. Saan siya nag-start? Sa 40. So, we will draw line from 40 to this point. Okay, doon sa 80. Ngayon, paano natin kukunin yung area niyan? Ano ba yung nabuo nating shape? So, in this case, hindi lang yan isang shape. Meron tayong dalawang shape dyan. We have a triangle and a rectangle. Okay? So, ano ba yung area muna natin uli ng rectangle? So, area uli natin ng rectangle is length times width. Okay, lagyan na lang natin. Yan, para hindi tayo malito. So, ang length uli natin dyan is yung una nating force is ilan? So, yung length natin is 40 newtons. And then, ang ating width or displacement niya is 10 meters. Okay? So, yan ay 400 joules. Ito pa lang yun, yung rectangle. How about yung triangle? So, ang area natin ng triangle, recalling sa geometry, is 1/2 base times height. So, 1/2. Ano ba yung base natin dyan? Siyempre, yung ating 10 meters or yung ating displacement. So, 10 meters. And ano ba yung height or yung nire-represent na ating height? Yung 80. Kaya lang, yung height natin, hindi naman siya buong ito. Kasi nga, nakuha naman na, hindi siya mula dito sa point na to hanggang 80 dahil nakuha naman na natin yung 40. So, magiging siya? 80 minus 40. Okay? Kasi yun na lang naman yung height na kailangan natin. Hindi na natin kailangan itong 40. So, magiging yan ay 1/2 times 10 meters, newton. Bigyan natin unit. Times 40 newtons. Okay? So, we will get 1/2 times 400 newton meter. Okay? So, divide natin. So, ang area natin ng triangle is 200 joules. Okay? So, hindi pa yan yung final natin na work. Sabi nga natin, yung work is yung area under ng curve natin. So, ito yung nabuo nating curve or yung line. So, area nung dalawa. So, kailangan lang nating i-add yung dalawa nating nakuhang area. So, adding the area of rectangle and the area of our triangle. So, we add natin siya. We will get 600 joules. Okay? Another way para makuha natin kung ano yung work, halimbawa wala tayong given na graph na ganyan, so hindi natin kinuha yung area ng bawat shape, kailangan lang natin kunin yung average ng force kung meron tayong kung meron tayong more than one na given na force. So, para makuha natin yung work, so another method is yung average of force times the displacement. So, ano ba yung ating forces? So, we have 40 newton plus 80 newton. Kasi nga average siya. So, i-divide natin by 2 or ita-times natin sa 1/2 times the displacement. So, add muna natin. So, 120 newton divided by 2 times 10 meters. So, 120 divided by 2, 60 times 10. So, 600 newton meter or joules. So, same lang yung makukuha natin na value. 600 joules of work. So, we have another example. So, this time, mas marami tayong nabuong shape sa ating graph. Okay? So, i-plot muna natin. So, yung ating force by 10. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, negative 40, 50, 10, 20, 50. So, ito yung ating force. And then, yung ating displacement So, by 1. Oh. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. So, pinulang. So, extend natin. Kinulang siya. Extend natin. Thirteen, 14, 16, 17. Okay, so we have, una is yung 20 newtons. And then going to 50 newtons sa displacement na 3. Okay? And then, sa displacement natin na 7 meters. And then yung force natin, same pa rin, 50. Okay, so plot lang natin. And then next is sa negative 40. And then sa displacement natin na 0.12. Okay, negative 40.12. And then negative 40 pa rin, pero sa displacement natin na 0.15. Okay, so connecting yung ating mga plots. So, we'll have this shape. Okay? Okay. So, in this graph, you will notice, hindi lang siya isang shape. So, we have various shapes. So, una, para hindi tayo malito, unahin natin itong malaking rectangle. Ayan, hindi pa natapat. Ayan yung ating malaking rectangle. And then, dito, hatiin pa natin siya. So, we'll have a rectangle and a triangle. So, meron tayong malaking rectangle and malaking triangle. And last, we'll have one triangle and one rectangle. Okay, so para makuha natin uli yung force, so kailangan lang nating kunin yung area ng bawat shape. So, unahin na natin yung area nito. So, since rectangle uli siya, so, lagyan natin area ng una. So, length times width, again. So, length natin ay 20 Newton times 3. Meters. Okay? So, we'll have 60 joules. So, lagyan na natin ng bilog. And then next, we have yung triangle natin. So, area ng triangle is 1/2 ng base times height. So, again, so 1/2. Ano ba yung base natin? So, same lang. 3 meters times yung height natin is 50. So, mula 50, so bawasan natin ng 20. So, magiging 30 newtons. So, 1/2 ng 90 Newton meter. So, we will get area ng ating triangle is 45 joules. Okay, so ito yun, ating triangle. How about yung ating malaking rectangle? So, itong ating rectangle, so again, area lang po ng rectangle. So, length times width. So, ilan siya? So, mula na doon, so 50 newtons times, tama, bilang tayo. So, from this point, so 1, 2, 3, 4. So, ang ating displacement is 4 meters. So, 50 times 4. So, we will have 200 joules para doon sa another area natin ng rectangle. How about yung ating isa pang triangle? So, we have, formula muna. So, 1/2 base times height again. So, 1/2 ng, so yung base natin, in this case, so ito yung ating second triangle. So, in this case, so ilan yung base natin? So, 3 meters ulit times, ilan siya? So, 50 newtons. So, we'll get half of 150 Newton meter. So, we will get the area of the triangle, which is 75 joules. Okay? How about yung ating triangle na isa pa sa baba? So, again, area ng ating triangle, 1/2 base times height. Okay, so 1/2 ng, so in this case, ang base natin is 2 meters times yung height natin is 40. So, disregard lang muna natin yung negative sign. So, 2 times 40, so 80 divided by 2, so 40 joules. Okay, kaya lang, tatandaan natin kapag yung ating curve or yung area ng mga shapes under ng ating curve ay nasa baba ng x-axis, lagi po yung negative. So, we will put negative sign. Okay? Kapag nasa taas naman ng x-axis, laging positive. Tandaan natin, dito laging positive. And dito sa baba ng ating x-axis, laging negative. Okay? Kaya dito, area natin ng triangle na to is negative 40. So, last one natin is yung area ng ating rectangle na ito. Okay, so area of rectangle. So, ang ating length muna is 40 Newton times yung ating displacement or yung ating width is 3 meters. So, we will get 120 joules or negative 120 joules. Okay. Ngayon, para makuha natin yung work ng buong graph na yan, kailangan lang uli nating i-add lahat ng nakuha nating values. So, let's start with 60 plus 45 plus 200 plus 75 But this case, since negative siya, minus 40. Ito pala. So, minus 40 minus 120. So, ang total natin, 60 plus 45 plus 200 plus 75 minus 40 minus 120. So, we will get 200 joules. If work is the product of an applied force which causes an object to move, then how can we have work? The answer is energy, or in terms of energy. So energy, it is the capacity to do work. Diba nga kahit tayo, halimbawa, sa pag-aaral natin, hindi natin kayang mag-aral or wala tayong sa mood na mag-aral kung wala tayong sapat na energy. Yung mga nagtatrabaho, yung mga parents natin, they cannot work if they do not have the energy to work. Okay? So we have two kinds of energy, the potential and the kinetic energy. So we have potential and kinetic energy. So if you can recall, sa elementary or sa junior high school, when we say potential energy, it is the energy at rest. And kinetic energy, it is the energy in motion or in a moving object. Since sabi nga natin sa work, pag nag-apply tayo ng force and nagawa niyang pagalawin yung isang object, so merong work. And then since ang ating energy naman is the capacity to do work, then yung mga gumagalaw na objects, meron silang energy. And yun nga yung tinatawag natin na kinetic energy. Okay, it is the work done by a moving object and is equal to the change in its kinetic energy. Okay, yung work. So, kung maaalala nyo yung second law of motion natin, which is yung law of acceleration, we have the formula force is equal to mass times acceleration. And yung formula natin sa velocity and acceleration dati, yung final velocity is equal to initial velocity squared plus 2AD or acceleration times displacement. Okay, so from this formula, makakabuo tayo ng formula natin ng kinetic energy. If work is equal to force times displacement, we can substitute the value of force using Newton's second law. Okay, so this one. So we will have the formula work is equal to mass times acceleration times the displacement. Okay, how about the acceleration times displacement? We can also substitute that value with this formula. Okay, But first, kailangan muna nating i-substitute yung formula natin for acceleration times displacement. So, paano ulit? So, transpose lang tayo. So, final velocity is equal squared pala nalagyan. Final velocity squared is equal to the initial velocity squared plus 2 times acceleration times the displacement. So, dun sa last nyo, wala na siyang naka-indicate na F. Okay? Or yung indication na final velocity siya. Pero yun yung final velocity. Kasi mamaya, kapag nag-derive na tayo ng formula for kinetic energy, i-disregard na natin yung subscript natin na F. Okay, so to get the formula for acceleration times displacement, so velocity squared plus 2AD. So, we just need to transpose. So, minus. So, small v and small v. Initial velocity squared is equal to 2 times AD or acceleration times displacement. And then to eliminate 2, we can divide both sides by 2 or multiply both sides by 1/2. Okay, to cancel 2. So we will get half of final velocity squared minus half of initial velocity squared is equal to AD. Okay, so this is our formula for AD. Now we can use this and substitute the value in this formula of work. So we will have the final formula for our work. So mass times AD is equal to half of square of final velocity minus half of square of initial velocity. Okay, so to simplify, so 1/2 of mass times final velocity minus 1/2 of mass times squared of initial velocity. So that is our formula for work. Or pwede pang mas simplified pa. We can also write it as mass times final velocity squared over 2 minus mass times initial velocity squared over 2. So, pareho lang yan. Now, considering na yung object natin is nag-move siya from rest, and then yung motion niya, yun nga yung nagkaroon na siya ng kinetic energy. So, therefore, yung ating initial velocity, ito, mawawala na yan. So, this will be cancelled out. Okay? So, for our kinetic energy, our final formula will be kinetic energy is equal to what? Is equal to, pwede alin dyan sa dalawa. Kinetic energy is equal to half of mass times final velocity squared. So, yan ang ating final formula ng kinetic energy, or yung pangalawa, mass times final velocity squared over 2. So, yan yung final formula natin for kinetic energy. So, if work is done on an object, kinetic energy increases. But if this object does work on another object, its kinetic energy decreases. Anong ibig sabihin nun? Halimbawa, let's say, for instance, itong dalawang colored pencil. Okay? Sabi, so if work is done on an object, yung kinetic energy niya is nag-i-increase. So, halimbawa, ito yung object natin, na-apply natin ng force para magkaroon tayo ng work. So, nung minove natin siya na ganyan, yung kinetic energy nito, nag-increase siya. Kasi siya yung nagkaroon ng work or in-applyan natin ng force. And at the same time, ito naman, okay, yung object natin na nagkaroon ng work or nagbigay ng work doon sa ating yellow-green na colored pencil, siya naman ay nag-decrease ng kanyang kinetic energy. So, tatandaan nyo yun. Kasi kaya pag mayroong mga problem na ganun, so, i-identify lang natin alin ba doon sa dalawang object yung gumawa ng work. So, kung sino yung gumawa ng work, okay, yung gumawa ng work, magdi-decrease yung kanyang kinetic energy. And yung ginawa ng work, okay, siya yung mag-i-increase ng kinetic energy. Kasi nga, halimbawa, yung kanina. So, from rest, then gumalaw siya. So, anong nangyari? Nag-change yung kinetic energy niya, so mag-i-increase yung kanyang energy kasi nga from rest siya. And then, ito naman, sa kaso niya, so from this situation, so anong nangyari? Siya yung nag-apply ng work or siya yung gumawa ng work, pero anong nangyari bandang huli? Siya naman yung napunta sa rest. So, nagdi-decrease yung kanyang kinetic energy. Now, let's proceed to potential energy. So, potential energy, we have there three forms. So, we have gravitational potential energy, chemical energy, and elastic potential energy. So, yung gravitation start na tayo sa chemical energy. So, yung chemical energy, yan yung mga energy na tinataglay ng mga atoms or molecules, usually ng mga living organisms. Pero hindi ibig sabihin nun wala yung mga non-living things. Okay? Yan yung energy na nakadepende rin sa kung anong klase ng substance ang isang bagay. Okay? Usually yan yung mga nag-undergo ng chemical reaction. Maaring from one energy to another energy. Kaya nga, di ba, minsan narinig natin yung term na transformation of energy. Okay, so yun yung chemical energy. Now, in physics, ang focus lang natin is yung dalawa, which is the gravitational potential energy and the elastic potential energy. So, yung una, gravitational potential energy. Okay? So, sabi dyan, it is the energy possessed by an object due to its position. Okay? It is determined by the height of an object above the Earth's center of gravity, and every object on the Earth's surface possesses this energy. Okay? So, kahit anong bagay na nasa Earth, meron yan. Kasi nga, di ba, lahat naman ng bagay sa Earth is na-attract ng gravity. So, balikan lang muna natin yung potential energy pala. Potential energy is the energy at rest. Okay, again, kinetic energy is the energy in motion and potential energy is the energy at rest. And usually, ang symbol natin for potential energy is the big letter U, the capital letter U. Okay? So, kung maaalala natin, yung formula uli natin ng work. So, we have work is equal to force times displacement. Okay? This time, para ma-substitute natin yung formula ng force, so, applying uli yung law of acceleration. So, ano ba yung law of acceleration natin again? So, force is equal to mass times acceleration. Kaya lang, if we're talking about gravitational potential energy, so may gravitational force na involved. So, ang gagamitin nating formula is yung weight is equal to mass times gravitational or acceleration due to gravity. Okay? And then, di ba, nasabi natin sa mga unang lesson, equal yung dalawa na yan. So, therefore, pwede natin siyang i-substitute. So, magiging work is equal to mass times gravity times displacement. Kaya lang nga, sabi natin dito, it is determined by the height of an object, okay, above the Earth's center of gravity. So, sa halip na letter D, or yung displacement, papalitan lang natin siya ng height. Okay? So, we will have the final formula for the gravitational potential energy. So, potential energy, subscript natin ng G. So, mgh. Okay? So, mass. So, M is equal to mass, the object. G is equal to the acceleration due to gravity. And yung ating H, yung ating height from the Earth's surface. So this is our final formula for gravitational potential energy. Yan. Mas madali siyang tandaan. So the last form of potential energy is the elastic potential energy. So from the word itself, elastic. So it is the energy possessed by an object like a spring or any elastic material. Okay, due to its condition. So yung material, 'di ba, kagaya nga ng spring, yung kapag kinompress mo siya, bumabalik din siya dun sa dati niyang position. Okay? So, let's say, for an instance, so, yung nasa picture natin, so, di ba, meron tayong box. Okay. So, let's say, we have spring in between those boxes. So, sabi dyan, work is done on the spring to compress it, and in the process, it acquires potential energy. So, para magkaroon siya ng work, or, syempre, kailangan natin ng force. Okay? So, applying force, halimbawa, may lalaking magtutulak nung ating isang box. So, ito muna yung una. So, kapag tinulak yan, okay? Kapag tinulak siya, anong mangyayari doon sa spring natin? So, magiging compressed siya. So, that is the time na magkakaroon siya ng potential energy. Okay? Which is nakadepende dun sa force na in-apply natin para makompress yung ating spring. So, para makuha natin yung elastic potential energy, we're going to use the Hooke's law. Okay? Yung Hooke's law, yun nga yung about sa ating spring na material. Okay? So, it has the formula F is equal to Kx. Okay? So, ano yung K? So, yung F, syempre, yan yung force. So, force applied. And then, yung ating K, di ba, kapag K constant, so in this case, dahil nga elastic potential energy siya, it is the spring constant. Or kung may iba pang elastic material tayong ginamit, so depende sa material, yung spring constant natin. And yung X, yung position or yung distance Okay? Na kung saan siya nagalaw. So, halimbawa nga, kung una, nandito yung distance natin, so within this area, and then nung nagalaw siya, napunta na yung box dito, sa point na to, so ito yung i-measure natin na distance ng box. Okay? So, since sa example nga natin, sa umpisa, hindi pa naman or uncompress pa yung ating spring, so let's say, yung force natin dyan is 0 muna. So, initial force natin. And, in this case naman, ito sa final force natin, let's say, halimbawa, example lang natin is, apply tayo ng 20 newtons, halimbawa. Okay? So, nagkaroon tayo ng force. Okay? Nag-apply tayo ng force sa ating object. Kaya nagkaroon ng work. Okay? Kasi nga, nag-move siya. So, yung spring, yan po ay nakadepende sa force. Okay? Which is, kailangan natin kunin yung kanyang average. So, average, siyempre pag kukuha tayong average, ano ba yung mga values? So, ano ba yung value muna natin ng force? So, kx. Halimbawa, so dalawa lang naman yung force na nasa example natin. So, halimbawa is sub 1 plus kx sub 2. Since average siya, so dalawa yung example natin. So, i-divide lang natin siya sa 2. Okay, yan yung average force natin. Ngayon, kung yung spring natin ay galing na siya sa 0, so, kung ganyan ang scenario, so substitute uli natin yung value. So, force is equal to K x sub 1 or yung initial natin plus K x sub 2 or yung final force natin over 2 times yung position. Okay, or pwede rin naman nating isulat yan na or 1/2 kx1 or I plus 1/2 kx sub 2 or f times, so lagyan na rin natin ito ng parenthesis para hindi nakakalito, yung ating displacement or yung pag-change niya ng position. Ngayon, since yung ating initial na force is 0, so we are going to eliminate these quantities. So we will only be left with 1/2 of kx times x or half of spring constant times displacement or change in position squared. So that will be our final formula for elastic potential energy. Okay? Or pwede rin naman natin siyang isulat na elastic potential energy is equal to kx squared over 2. Sa ibang book, sa halip na U sub E, ang gamit nila is EPE. Okay? For elastic potential energy. Same thing with the gravitational potential energy kanina. Sa halip na U sub G, minsan ang gamit nila dun is GPE. Okay? So, those are the potential energies. Okay, so last concept natin sa energy is the law of conservation of energy. So, gamitin na natin tong space na to. So, law of conservation of energy. Okay? So, it states that Energy can neither be created nor destroyed, but can only be changed from one form to another. Okay, siguro ma'am, familiar na kayo dyan nung high school, ano? Pag sinabi natin law of conservation of energy, yan yung sinasabi natin na ang energy cannot be created and also it cannot be destroyed. Sa halip, pwede lang itong ma-transform into another type of energy. So, pwede nating express yung law na yan into an equation. So, halimbawa, we have change in kinetic energy plus the change in potential energy plus the change in any other forms of energy kung meron. Okay, is equal to 0. Okay? Sabi nga natin kanina, pwede tayong mag-change ng energy. Pero, hindi siya mawawala. Okay? Or hindi siya masisira. Mag-change lang siya into a different form. Okay? Pero yung total energy natin is constant. So, halimbawa, kung sa physics ang pinapag-usapan natin, we're only talking about the mechanics. So, we're only talking about kinetic and potential energy. Okay? So, yan yung ating formula or yung ating expression. So, transposing potential energy to the other side. So, we will have kinetic energy is equal to negative potential energy. Okay? So, anong ibig sabihin yan? Ibig sabihin lang yan, the change in kinetic energy is equal to the change in potential energy. Ano yung ini-indicate ng ating negative sign? Ibig sabihin, kapag nag-i-increase yung ating kinetic energy, nagde-decrease yung ating potential energy. Or, kapag nawawala yung ating potential energy, nagkakaroon tayo ng kinetic energy. Kagaya nga nung kanina, halimbawa, ito yung ating may potential energy, ito yung ating may kinetic. So, anong nangyayari sa ating potential energy? So, kapag nag-apply tayo ng force, so yung ating potential energy, mag-gain tayo ng kinetic energy. And itong ating kinetic energy, kapag nag-apply tayo ng force, magkakaroon siya or mababawasan siya ng potential energy. So, yun yung ating law of conservation of energy. So, ito yung pinaka-representation niya talaga para makita na rin yung relationship nilang dalawa.